As the grid gets more digital and more complex, utilities are under pressure to standardize, virtualize, and still keep their systems secure and reliable. So how do you actually pull that off in real-world substations?
This is Powering the Future, a podcast series brought to you by Smart Grid Forums. One planet, one power grid.
Joining us today is Stefan Hufnagl from Copa Data, here to show us how their Zenon platform is making substation automation more standardized, virtualized, and secure. Stefan, hello. Thank you so much for joining us today. It's great to have you on the podcast.
It's great to participate in the podcast. Thank you, Mandana.
So, Stefan, it would be great, before we get started with the conversation, to know a bit more about Copa Data's market position in terms of substation virtualization and your own role in supporting the sector.
Okay, so Copa Data is a private software company which has been founded almost 40 years ago in Austria, and in the early 1990s, the development of the Zenon software has started. And since then, it evolved from an HMI SCADA system into a comprehensive software platform, which is used for industrial automation, which helps users to digitalize, control, and streamline critical processes in energy, but also in other industrial segments like pharmaceutical or food and beverage or automation manufacturing, for example, automotive manufacturing. Right. And all these application domains require highly consistent and robust solutions. So there would be a lot of things to mention, but in a nutshell, I can say that Copa Data and Zenon built the foundation of successful integration and operation of critical assets for many utilities across the globe. I'm personally dealing with industrial automation for more than 20 years now, and I entered Copa Data in 2013 as a product manager for our integrated soft PLC environment. Since 2019, I specialize on the energy market, and I try to contribute to the development of our capabilities there. So in fact, I'm in close contact with the industry on the one hand side and with our technical and commercial departments on the other side.
So Stefan, one of the areas that you're really focused on, which I think the whole industry is focused on, is substation virtualization. This is a hot new topic. It's been discussed for some years, but we really get the sense that the utilities are jumping on board with this opportunity now, albeit they do have some concerns and some questions. But what are you seeing among utilities in terms of their appetite for virtualization and then the products that will follow?
So, yeah, there are definitely a lot of challenges in detail, and probably a rather big chunk, which I could take, which a lot comes down to currently, in my perception, is the ongoing grid modernization and expansion. So for utilities, it means significantly increased workload, extending the grid's capacity, and with new substations or new power lines or probably other assets, or bringing in new technologies in order to get out more of the existing assets. Yeah. And in some parts of the grids, it's about the integrating assets which haven't been part of the grid before at all, or of the centrally visible systems. I think low voltage visibility is a major buzzword here, for example. Mm-hmm. And in the end, it means more projects, both greenfield and brownfield, need to happen in the same time period. And at the same time, the asset inventory, so the number of sites and systems which need to be taken care of during the entire plant life cycle, grows significantly. And this, again, happens in the background of increasing shortage of skilled workers, at least in some parts of the globe. So that means there is a high demand for more scalability and flexibility. Mm-hmm. And yeah, that's where virtualization kicks in, I would say. And as a software company, we deal with virtualization already for many years in various types of applications. Mm-hmm. And in the special case of substation automation, it's especially the virtualization of protection, automation, and control, so namely the VPAC component, or the deployment of and operation of virtual IEDs, which is most crucial and the most demanding discipline, so to say. So the Zenon software platform is mainly utilized for station-level applications like a substation HMI or a substation server or a virtual gateway, for example. So Zenon is not immediately involved in the process bus and protection functions, but we definitely see some potential to enforce the usage of our technology for advanced control and automation features in centralized and virtualized architectures.
Right, okay. So the technology is there and it's evolving. It has great potential. In terms of customer demand, what are you seeing in terms of appetite, uptake, and scaling of virtual substations?
So it shows that in the recent years, virtualization has come a big buzzword, and there are many and more projects upcoming, pilots, proofs of concepts, but also already productive applications. Also, we always see at Copa Data the continuity between um, the different innovation steps. So there are still conventional substations out there. There's digital substations, so 61850 based substations, and at the same time, the utilities are looking forward and innovate towards virtualization concepts. So staying with IC 61850, this has been a key technology in our substation solutions for many years already. And we consider that a key technology for the further evolution and acceptance of at least open and vendor agnostic substation solution. This is where we see an accelerating trend towards virtualization, getting familiar, getting to grips with all the technologies, the processes on the one hand side. But at Copa Data, we are also aware that our users will still have to operate existing and legacy substations for many years to come.
And the migration from traditional substations to digital substations has been successful to an extent, but a full 61850 substation has been a bit slower to be adopted by the sector, by the utilities, I think. What do you think we need to do differently in order to fast track the migration towards virtualized substations? What can we do in terms of simplifying the technology, its application, its maintenance, and upskilling the workforce, which ultimately is the determining factor as to whether these technologies succeed or not?
Yeah, we have to come up with simple tools and good examples. Yeah, we have to see the fact or help the users really to innovate gradually while they have good solutions also to operate in a mostly unified environment their existing assets. So that's conventional substations, digital substations, and then towards virtual substations. And only looking at digital substations, for example, you could have different flavors of that, right? So it's always a very heterogeneous environment in the practical utility context. You would have, even just talking about 61850, you would have or you can have edition 1 devices next to edition 2.0 devices, next to edition 2.1 devices. And we as a software company strive to support our users to being able in a simple way to operate all these different system generations, often also from different vendors, in one unified and integrated system.
Yeah, Stefan, one word, one buzzword that keeps cropping up when I talk to people working the utility side is simplification. Simplification. How do you think the equipment manufacturers, the solution providers, I should say, like yourselves, can really simplify these applications and make them much more user friendly and therefore boost the uptake much more quickly?
Yeah, at Corporate Data, we try to solve these challenges I've already mentioned by systematically neutralizing emerging complexity for the people who interact with the solution. So that's engineers on the one hand side and operators on the other hand. So if we look at the engineering side, Zenon follows a no-code philosophy. That means the complexity of certain functions is entirely encapsulated. So as a substation engineer, you can implement substantial features for substation connectivity and control with only a few clicks and no programming, for example, are required.
Mm-hmm.
The crucial point here is that the technical mechanisms behind these features are pre-integrated for all different device editions. So you can, for example, integrate control devices via Modbus or IEC 101, IEC 104, DMP3, or 61850 in the mentioned editions next to each other using the same configured interface.
Mm-hmm.
Another thing to mention is, for example, engineering automation. So that the capability to automate engineering steps. Every single item in a Zenon project can be accessed via an API. And that means that through custom scripts and wizards, you can generate the engineering configuration. So our customers use this for the rapid generation of substation HMI projects, for example. So you have got the objects, for your typicals, for example, you try to standardize and integrate that, and you get your structural information from, let's say, an Excel spreadsheet or an XML model, or ideally from an IEC 61850 SCD or STL file, or from an ICT. So whichever framework you have, you can profit from the direct use of your available data and build an integrated and robust development chain. Now we've looked at the engineering perspective. If you look at the operations perspective, on the other hand, I'm convinced that integration needs to help people to cope with systems in information diversity in applications. A good substation HMI today, for instance, has to unify the operation of many different devices and systems, primarily, of course, protection, automation, and control devices, but also for other systems like networking equipment, security system, or auxiliary systems. If you look at offshore platforms, this is a particularly good example for that, as offshore platforms combine really a lot of separate trades and technologies. And if in a substation something goes astray, let's say something goes wrong with a network switch or access control system, or otherwise something cyber security wise, I want to have the chance to notice that via the same interfaces or notification processes as with my regular process O&M. Mm-hmm. This will help to lower the mental burden of operators and definitely improve situational awareness. Also, during incident investigation or for long-term data analysis, it's a clear benefit having this information aligned and integrated.
Okay, fantastic. Well, it sounds like some innovative approaches within the Copa Data suite. And of course, Stefan, your group are going to be at SGT 26 in Paris in March. You're running a live demo room, and our utilities can come along, schedule a one-to-one session with you, learn more about your approach and your tools, and ask you questions that are specific to them. So we look forward to having you and your team on site and demonstrating your solutions then. Thank you so much for joining us today. You have a great day, and we'll catch up with you again soon.
Thank you very much, Mandana.
Join us again next time as we unpack another big topic shaping the future of the power grid. Don't forget to subscribe to our YouTube channel, Smart Grid Forums, and to follow us on LinkedIn. Until then, thanks for watching and listening.
This is Powering the Future, a podcast series brought to you by Smart Grid Forums. One planet, one power grid.